Chapter 9, serial correlation. And let's see what homework John Harvey assigned for this one. Let's see, we've got number 3. Oh, I love this question. He's done this in previous editions. Okay, I need to show you this, and we're going to work through it a little bit. On number 3, he's going to show you, where am I here, John? Down the bottom. Recall from section 9.5 that switching the order of data will not change the coefficient estimates. A revised order will change the Durbin-Watson statistic, however. To see both these points, run these regressions and compare the estimated coefficients in the DW statistics for these data. Now, here's what you're going to do. You're going to type these data into Stata. Hey, that rhymes. And then run it in the order that they're listed. Run it in the reverse order. And then run it in that sort of strange order down there in part C. All right, and what you're trying to see there is how, now it doesn't actually ask you to comment on it, does it? No, it just wants you to see how the coefficients don't change, but how the Durbin-Watsons may. Let me turn the slide off. And since you've just finished watching about this chapter, I assume you know what serial correlation is. It has to do with the error terms being correlated over time. All right, so let me show you how you do this one. Let me shut this down and open it up again. So you're going to have to open up Stata. This time there isn't a data set to go to. So you're going to have to go up to something I showed you in an earlier video, Data Editor. Right there. Hold your cursor over it, it'll show up as Data Editor, all right? Click. There's the Data Editor. Now, I'm going to type these numbers in. So if you'll bear with me here for just a second, and I'm going to do 1, 2, 3, 4, 5. Okay, there's the years. 9090, 89, 42, 97, 55, 10, 327, 10, 327, 10513. 10513. And then, for the third variable, which is going to be population, 2200, these are housing starts, and population, 2222, 2244, 2289, 2290. Now, see where it says variable 1, variable 2, and variable 3? That's not very helpful. So click on variable right there. Go right down here to the bottom right, where you see name in VAR1. And if you highlight, or let's just put the cursor right there at VAR1 and backspace over it, year. Let's make that year, all right? And then this first variable here is actually housing starts. So let's go over here to variable 2. Maybe put starts. Notice I'm using all lowercase because this stupid thing is case sensitive, and so I don't want to have to remember to do capitals. This is population. Oops. POP, or whatever you want to call it. All right. So now you get your data. Now you can close this window, and then in command, regress starts population. All right. And let me double check. I've run all these regressions already. Let me double check my answers here against what I did yesterday or the day before, whenever it was. Yeah, that looks right. Okay. So you're going to do what you always do. Now notice here that the thing where it has your name way up on the registered thing is way up above. So don't worry about it, all right? As I said here in the homework, FYI, don't worry about showing your identifying information on this one. It would be a royal pain to go back up there and capture that too. So just get that much of it and copy that. But now you're going to, so okay, watch me. Copy this picture. So over here, I'm going to write, what number was this? Number 3A. There's the regression results with the coefficient estimates, but not the Durbin-Watson yet. Okay, I need to do the Durbin-Watson. So, oh, you know, actually I should have done this first. But anyway, TSET. I went over this in the video lecture. TSET means time series set. This is a time series. And which variable is the one that's counting the years, or counting the time here? It's the one I called year. So TS set year. So if I do TS set year, in fact, here, let me, well, no, I don't want to do that. Okay, so TS set year. Now I want to run the regression again. Oh, but check this out. If I want to run the regression again, there it is, right there. See on line 24? No, I'm not going to type it all in again. I'm just going to click on it. There it is. All right. Now I'm going to get the Durbin-Watson. And for the life of me, I don't remember how to do that. Let's see. It is, E stat D Watson. There's the Durbin-Watson statistic. All right. So now you would want to do this. Copy as picture. Oops, don't highlight that. Paste. There it is. Now it's below it. Okay, so there's 3A. Do the same thing for 3B and 3C. Now let me give you some advice here. When you got to do 3B, you're going to have to reverse the order of all these data, right? Just retype them. Just type them all back in again. It's the easiest thing to do. It's a little tedious, but it's the easiest thing to do. So you're going to type them in from 5 to 1 and reverse the order of all these numbers. And then for part C, you do them in the order of type in year 2, then year 4, then year 3, then year 5, then year 1. All right? As you can see there in that homework assignment right there. And since I threw you off a little bit here, every time you do those 3, I ran my regression first, and I probably should have done the, I'm not sure if it made any difference, I don't know, but I probably should have done the TS set first. Let me write out here what you should do every time. And that's right on that last command, isn't it? Yeah. Okay, so every time after you type the data in, all 3 times, T set year, regression starts population, E stat D Watson. That should give you all the numbers. That's a really good question because notice what happens. It's very interesting. All right, so let's go back to the homework, which is right here. And yeah, that's it for number 3. Number 5A, you got to test for serial correlation at the 5% level. Now, if you look back at the regression, it gave you a Durbin-Watson statistic. So I will leave it to you, since I've already gone over this in a different lecture, or in the lecture, to figure out how to do this, but you'll need to have the number of observations, which is right here at 40, the number of explanatory variables, which is right there, and then the Durbin-Watson upper and lower levels, and the one that this generated was a 0.85, so you want to do that test. And be sure to, in your homework, tell what the critical upper and lower levels were, all right, so that I know you looked up the right thing on the table. Let's see, that was 5A, 5B. Make and test the appropriate hypotheses about the slope coefficients. You're once again doing t-tests, all right? And 5C, compare the size and significance of the estimated coefficient of L with that for P. Is this difference surprising? Is L an irrelevant variable? Explain your answer. Just do that one. Think through it. And D, if serial correlation does exist in this particular regression, would you expect it to be pure or impure, and why? And I don't care which one you answer. I do care about your why. All right. Okay, let's see. That's that was 5, right? So here comes 7. 7A. Test equation 9.32 for serial correlation using the Durbin-Watson test at the 5% level. You've got a Durbin-Watson, you've got the number of observations, you're all set there. So it's giving you all the stuff. And my recollection is, from having done this lecture video a couple of days ago, that the only Durbin-Watson numbers they give you are the 5% level. Yeah, I mean, that's why he keeps saying, do it at the 5% level. Well, that's because that's the only values I gave you in the book. Right. And then B, C, and D, what were those? Why might the linear functional form be inappropriate for this study? It's the putting one again. So think about that. So then C, let's re-estimate it with a double log. With a double log form, and he shows you the double log form. And test this one for serial correlation using the Durbin-Watson test at the 5% level. And then finally, did I ask you to do D? Yeah. Finally, on part D, which of those two equations do you prefer and why? Do you prefer the one that was in this sort of the linear form, or do you prefer the one that was double log form and why? And that's chapter 9.